All right, in number 4 right here, they've told you here that a factory is producing bicycles at a rate of this function here, 95 plus 3t squared minus t. So I went ahead and wrote that function out right here, and I called it b of t. You can call the function whatever you want, guys. It doesn't really matter. But what I think is really important is that we notice the units right here of what we're dealing with. Bicycles per week, and it tells us that t is being measured in weeks. So that bicycles per week is really important. What we're dealing with right there is a unit that is a rate. So if we were to think about this in a context that's easy for us to understand in terms of a position, velocity, or acceleration problem, this function right here that I've called b of t is almost kind of like a velocity. A velocity might be measured in meters per second or miles per hour. Bicycles per week would kind of fit in that rate category right there. And the question now is, how many bicycles were produced from the beginning of week 2 to the end of week 3? Okay, so first things first. The question is, how many bicycles are there? So the function we've been given is bicycles per week. That's why we can't simply put a numerical value here in for t, like for example 3, okay, and put something in there, because if we put any number in for b of t, we wouldn't be getting a total number of bicycles total. We'd be getting a rate, bicycles per week, which is not what we're looking for. So the way we're going to go from bicycles per week down to just plain bicycles by themselves right here is we're going to have to do a definite integral here. All right, and you'll see why that works in just a second. So we're going to do a definite integral of this function here, 95 plus 3t squared minus t. Now, this is where the variable of integration at the end of an integral that you guys tended to ignore for all of chapter 5 up until this point really becomes important. I think every one of us knows this is going to be dt at the end because t is clearly the only variable we're dealing with here. But if we think about units, this integrand right here, just like this original function, is being measured in bicycles per week. And then dt, which of course is kind of a variation on delta t, change in time, is going to be measured in weeks. So what we're doing here, guys, is we're basically taking this rate function of bikes per week, and then remember, this is multiplication right here, even though we don't usually write it, and multiplying it by dt or delta time, which is going to be in weeks. And when we multiply bikes per week times weeks, the weeks cancel, and we're going to end up with a total number of bikes, which is what we're looking for in this problem. Now, the only thing left to talk about here, guys, is what are the limits of integration? And they word this problem in kind of a weird way. How many bicycles were produced from the beginning of week 2 to the end of week 3? So if we were to think about a number line right here, guys, and this being our time axis right here, okay, and obviously we're starting right here at the origin at 0. All right, and if we were to think about weeks right here, guys, and just kind of make a few of them out here. So we're measuring weeks, and this would be week 1 and week 2 and week 3 and week 4. But really, the weeks kind of belong in the middle of these intervals here, okay? The first week would have been in that first set right there, so I don't really like where I put that there. This would be the first week right here. Here's the second week. You would never talk about the 0th week of production right there. So there's your third week and there's your fourth week right here. But again, labeling my axes here, 1, 2, 3, and 4 would look something like that. We're talking about beginning our measurement right here at the beginning of week 2, which is going to be at this spot right over here. So we're going to use 1 as the lower limit of integration. So you could read that the beginning of week 2 is really the end of week 1, and that's where we're starting to measure this. And we're going now until the end of week 3, and the end of our third week is right here, so 3 becomes our upper limit of integration. And that should set up everything that we need here. This does not look like a function that I think we're going to need to integrate by hand. So I'm going to go to the calculator right here, and we're going to go, for you guys, it's going to be menu, and then you're going to hit 4 for you guys for calculus, and then 3 for definite integral. And we are going from 1, we said, up to 3, gotcha. And our integrand now was going to be a 95 and then a plus 3 t. Let's see, I can get to a t. There we go, 3t squared. Gotcha. And then a minus t at the end of all that. And of course, you could just use an x if you wanted to, but this will work. And we're integrating all that with respect to that same variable, t. And when we hit enter here, that gets us 212. And I believe that's going to be our answer to this problem here. So 212 total bicycles is what's going to be produced within this 2-week window right here in problem number 4.